Okay, now we start with a quiz. And normally we do this, but we're 3 weeks into the course and we haven't been able to start with quizzes because we've only met full time as a class. Have we ever met full time as a class or full period? Not sure we ever have, and we've met half a few of the classes. So, we're way behind here. Um, so we haven't been able to do the quizzes anyway. So we've got to get on track. Okay, so we're going to find 5% of 730. Now, okay, the first problem is find 5% of 730. Now, 5% of 730 means, and incidentally, I think the last time I missed a class in school might have been the first week of seventh grade. Okay. I don't think I missed anything after that. And I've been teaching here for 53 years, and I still haven't missed a class due to illness. I've been sick enough to miss, but it's always been at a lucky time. Okay. So anyhow, but that's a background in the story. When I went into seventh grade, my math teacher was Bob Fife. He was the football coach. They named the stadium after him when he retired, and still named the Fife Stadium. He won a lot of games. He was a good guy. The first thing I remember was he welcomed me to class. And he said, we do this, we do this, we do this. And then he said, and this, took a paddle and slammed it down on the desk and said, it's what I do my talking with. Never had a discipline problem after that. He was the nicest guy, but he could be tough. Okay, and one of the first things I learned from him was that of means times. Okay, so it clarified for me completely for the rest of my life that of meant times. Okay, so anyhow, I don't know if that story helps or not, but that's the way school was back in the Wild West. Okay, so 5% of 730 means 5% multiplied by 730, which is over 100 times 730. And we've simply got to know that 5 over 100, we're going to take the 5 where the decimal is after the 5. We're going to move it over 2 points to the left because we're dividing by 100. So move it to here and to here. If we move it to here, we got to have a 0 here. So we move the decimal from the right of the 5 to the left of the 5, and then one more to the left, and we have to fill in a 0 there. And that's something you simply need to know. Okay, so now 5 times 7 is 35. 5% of 700 would be 35. And 5% of 30 would be 1.5. So I believe this would be 36.5, but I'm doing that in my head. Now I can multiply by the 3 and get 15, and multiply by 7, get 35, and carry the 1, and I still get the same thing. So that must be right. Is that what everybody got?
Yeah.
Okay. I lost out. Okay. So that's very straightforward, but we have to know what percent means. So it means 5% means 5 over 100. We multiply, of means multiply. We multiply 0.05 by 730. And we do need to be able to do a simple one like that on paper without reliance on a calculator. However, some of the later problems, we want to use a calculator, okay? Now, 12% more than 600. That means 600, and I am recording, okay. You're a little paranoid about that. It means 600 12% of 600. That equals 600 times plus 0.12 of 600. And everybody got to this. At least everybody got to the 12% of 600. Maybe a little question about what you do with that. Well, 12% more than something means you still got that something, you add 12%. Okay. So that's the concept. And you really want to think about that until it's second nature to you. Okay. So now I'm not going to multiply 0.12 times 600. 6 times 12 is 72, and you pretty much know what to do with the decimal point, but write it out carefully. You don't need to watch me make a mistake. Okay, so you get 672. All right. Now, that's not bad. And also, when you get down to the last problem, it's not bad. But I'll illustrate something with that last problem. 3% more than 10,000, 3% more than that, 3% more than that. That's how compound interest works. But before we get to that, the one that's a little bit harder is a number which, when increased by 10%, is 400. And the way we're going to solve that, let's see, we'll do it this way. Okay, we're going to say this. Number which, when increased by 10%, is 400, can be said this way. Let me back up a minute. One more thing I want to do with this problem that we did so I can do it here is it makes it a lot easier. Okay. I notice, and we talked about this in class last time, okay, that 12% more than 600 is 1.12 times 600, okay? So that means you have 1 times 600, that's your 600, and you have 0.12 times 600, that gives you 72, okay? And you can do that all in one calculation. You don't have to break it down like this, but you have to understand this breakdown before you understand why it's 1.12 times 600. And if you're not sure you understand that, you probably ought to go back and review the video from our last class where I explained that in a little more detail. Okay? Now, again, let's go back to the number, which when increased by 10% is 400. Want the number, which when multiplied by 1.10 gives us 600. Okay? Now, we got to get a little abstract here. We're going to have to use something to stand for that number that we don't know. Okay, so we're going to let n stand for that number. Then (1.10) times n equals, now I said 600 because I had 600 on the brain. Don't have all that much brain. There's 400 in this problem, okay, to match this up with the problem that we're actually doing. And I'm not sure you can see that problem over there, but you know what it is. So it should have been 400. So now, multiplied by 1.10, n should give us 400. That's an equation, 1.10 times n equals 400. Now, we're very shortly going to see how to solve linear equations. And many of you know how to do that, but we're not going to necessarily assume it right now. So take the 1.10 times n and divide by 1.10. That should equal 400 divided by 1.10. If I divide this thing by 1.10 and this thing is equal to 400, then when I divide by 1.10, it's going to equal 400 divided by 1.10. If I take two things that are equal and divide them both by 1.10, those two things will also be equal. And that's a basic principle of algebra. And you're going to see a lot more about that this week. Okay. So now if we divide 1.10 times n by 1.10, that's the same as saying we've got 1.10 divided by 1.10 multiplied by n over 1 equals 400 over 1.10. Now, I could have divided the 1.10 into 400, and that's perfectly legitimate. As a matter of fact, I recommend you use a calculator because it's a long division. Wouldn't hurt to refresh yourself in long division and do it to a couple significant figures, okay? So I kind of recommend that. But let's look at this now. Again, I claim that writing 1.10 times n divided by 1.10 is the same as 1.10 divided by 1.10 multiplied by n over 1. Why should that be so? Well, these are fractions. 1.1 over 1.10 is a fraction, n over 1 is a fraction, they're multiplied. How do you multiply fractions? You multiply the numerators to give you 1.10 times n, which is what we had before. And you multiply denominators to give you 1.10 times 1, which is just 1.10, and that's what we already had here. So it should be very clear if you just think about what you do when you multiply fractions. If you multiply 1.10 over 1.10 times n over 1, you have to get 1.10 times n over 1.10. Now we've done that backwards. If I gave you this fraction, you'd know what to do. If you see this, you don't necessarily know what to do, okay? But you can verify that it works since multiplying by the second fraction and multiplying the fractions gives us our original quantity. And that's important because, you know, what people are taught to do is cancel. And people don't understand the rules for canceling. I mean, some do, but in a pre-calculus course, 75% of the people who register for pre-calculus don't know the rules for canceling and do it wrong consistently. And I've even seen it among my second-year engineering students who will be juniors at Virginia Tech next year in an engineering curriculum. And they're still canceling wrong sometimes. That's rare, but I see it because it's really easy to do. And I understand it. You know, sometimes you just go by what it looks like and fail to follow the rules. Okay, well, end of lecture. Again, where we are. We want the number of which when multiplied by 1.10 gives us 400. 1.10 times n equals 400, where n is the number we're trying to find. We write that as an equation and divide both sides by 1.10. And we're down to 1.10 over 1.10 times n over 1 equals 400 over 1.10. But 1.10 divided by 1.10 is just 1. And n over 1 is just n. And 1 times n is just n. Okay, so I'll write the intermediate step. This says I've got 1 multiplied by n over 1 equals 400 over 1.10. I think it doesn't hurt to write that step instead of crossing out the 1.10s, which is mysterious to people at this level, often mysterious. Okay, and then we understand that n over 1 is n, and 1 times n is n, and this gets down to n. You can write those intermediate steps if you wish. Now you're going to divide 400 by 1.10, and that's approximately equal to 360, which is 10% less than 40. Okay, but if you add 10% of 360 to 360, you get 396, not 400. So taking 10% less than 400 is not the same as finding the number which, when you add 10%, gives you 400. It's got to be a little more than 360. Okay? And I'm saying it's got to be about a little less than 364, 363 point something, I believe. Okay? Now, divided by 1.10 gives you 0.90909090. And I could multiply that out in my head. It actually gives you, I think, about 363.6. Am I right? Okay. But that's because I happen to know what the reciprocal of 1.10 is. If you ask me what the reciprocal of 1.13 is, I don't have a clue. Okay. And this thing keeps repeating 3 6s. But that's just a coincidence of the number, and it just, something you don't need to know. I just mentioned it because it is good to have some arithmetic shortcuts. Okay. Sometimes they come in handy. Anyhow, we get the result. And then if you take 10% of this and add to this, it's going to give you 400. Now, I've only got 4 significant figures here. And that would come out just a little less than 400, like 399.7 or so. All right. And you could keep adding 3 6s. I think. And if your calculator doesn't tell you that, you understand there are limits to my thinking. Okay. But there, I think, is the number that would work. Okay, well, that's more than you need to know, but I really wanted to illustrate this solution of this equation, because that's a one-step linear equation, and that's something that's, I believe, assigned pretty soon, like maybe even for next time. Okay? So that's worth doing. Now, 3% more than 10,000. Equals, by what we've said already, 1.03 times 10,000 equals 10,300. Three percent more than that is well, let's be consistent. Not the way I write these down. Is 1.03 times 10,300. Okay. Now that's 10,309, I think. I mean, 10,300 plus 309, because 3% of 300 is 9. Okay, and 3% of 10,000 is 300. So we're adding 309. Okay. I mean, I said something wrong there, but 1.03 times 10,300, which is our former value, is 10,609. 3% more is then 1.03 times 10,609. Okay. Now, 3% of 600 is 18. 3% of 9 is 2.7, 0.27, sorry. So I think that should come out 10,628. And don't take that too literally. Use your calculator and get the right number. I don't like to use calculators. Did a lecture on dumbing down. If I use calculators, first place, it'd take me longer to do most of the calculations that I don't really have to do completely accurately. Second place, it'd make me dumber because I wouldn't be thinking through it. Be careful about the way you use AI. It has a strong tendency to make you dumber. We already talked about that. You know, one has a sister in middle school, and you know, everybody in middle school is doing their best to make themselves dumber. Okay. And teachers don't know what to do about it because they got too many students and too much to do. And of course, some of them don't really have a good handle on the whole situation, you know, because they're too busy doing other stuff. A lot of things I'd have a better handle on if I wasn't too busy dealing with technological meltdowns and other absurdities like weather. Okay, I can't do anything about the weather. Okay, anyhow, do you understand now? The point of this is that what's our increase? We increased by 300, then we increased by 309, then we increased by 318, and actually that should have been 627, I think. Anyhow, we increased by even more here because we get to add that 3% of our extra money, and our money starts accumulating faster and faster. Now, if your money accumulates at 3%, how many years should it take you to accumulate 100%? Because if you add 100% to what you have, you've doubled your money. Okay. Well, 3 goes into 133 and a half times. Okay. However, you double your money at 3% in about 24 years because you keep taking that additional 3% of a bigger and bigger amount. So it grows faster than you think it will. Okay. I can even make a graph just to, you don't need to be able to do these graphs. But right here's what you would have if you just added 3% of your 10,000 every year. If you add 3% to what you have at the end of each year, you get a curve that looks like it. So far, it doesn't look much different. Pretty soon it starts diverging and your money doubles 8 years faster than you would expect from this, which means if you keep that thing for 3 doublings, you're going to have a lot more money than you would if you just had simple interest, okay? That's a miracle of compounding. Populations grow like that too. So, you got invasive species. They've got no competition. They got plenty of stuff to eat. Until they eat up all the good stuff, they grow exponentially. That's an exponential curve. This is an exponential increase. Exponential is a term that people misuse, making mathematicians go around cringing all the time. Okay? And that's something I'm just mentioning at this point. Okay? The point is that adding 3% to your total every year makes your money grow faster. And if you compound your interest, take that 3% and divide it into 3. It's 1%. And you get that 1% 3 times every year, it grows even faster. That's compounded. Now, I'm not going to say much more about that right now, but that's something everybody should be aware of, just for your own financial future. Well, I'm going way beyond the whole thing. I'll just lay one more thing on you, and then we'll move on. I really didn't leave myself room to do this, but I'm going to do it anyway. I say this is 1.03 squared times 10,000. Why? Because we're taking 1.03 times 10,300, and 10,300 is 1.03 times 10,000. So if we take 1.03 times 10,300, what we're taking is 1.03 times 1.03 times 10,000. There are two 1.03s there, and they're multiplied. That means we have 1.03 squared. Here, this is another 1.03. It's 1.03 times what we had in the previous step. And what we had in the previous step was 1.03 squared times 10,000. We multiply by 1.03, we have another 1.03. That's 1.03 cubed times 10,000. So if you want to see what you have in 24 years, got a calculator handy? Anybody? It's okay. Okay. You take a calculator and do 1.03 to the 24th times 10,000 and check what I said. It should be pretty close to 20,000. It'll probably be just a little less or just a little more, but it's going to be pretty close. Okay, now I got to admit, I got out of sequence of what our assignments were. You've already done an assignment on linear equations, and everybody here has made 100% on that, okay? So that you know perfectly well how to solve this equation. The one we did for the 10% times n equals 400. You divide both sides by 1.10, simplify that, and you get your result, okay? Thing that I'll emphasize is you always want to check your work on a linear equation. Because if you get a wrong answer, first place open math is going to penalize you on it. That didn't apparently happen to anybody. That's great. Okay. But second place, open math will tell you it's wrong, but you didn't figure out it was wrong before open math told you. Okay. The way you figure out if it's wrong is you take this back here and plug it in for n and see that 1.10 times that equals 400 or very close because you have round off error. You're not going to write out 3 6s forever. Okay? Does that make sense? Okay, so just another plug for being sure you check your work. That really should be part of any solution, or at least any solution when you're doing something a little bit new that you're not really confident of. Okay? Okay, we're going to talk about a couple of things now. Formulas and inequalities. Formulas are kind of tough because everything's symbols. There are no, sometimes there are numbers, sometimes there aren't. Inequalities are not bad. You just got one simple rule you got to remember. It's different than doing equations, okay? But then you've got to represent your results and stuff like that. So yeah, we have to talk about that some. Okay, let's just take a formula. Let's just say AB equals CDE. And I say solve for B. Think about it for a minute. What's the thing you could do to both sides that's going to give you a solution for B? Nobody say, let everybody think for a minute. Okay, I think everybody pretty well understands this. We write AB equals CDE, and I put these a little bit above the equal sign because I know I'm going to divide by something, right? Well, if I divide by A, then that's A over A multiplied by B over 1 equals CDE over A. A over A is 1, so just got 1 times B over 1. B over 1 is B. 1 times B is B. And for that reason, I can write this out. I recommend you write this step out and think about what it means for another assignment or two. Then we'll talk about rules for cancellation. And the rule is simple. If you have a factor in the denominator that matches a factor in the numerator, you can divide them out. I still don't say you cancel them. You can divide them out. If you want to divide them out by crossing them out, go ahead. But think, divide them out. Because people cross things out that shouldn't be crossed out. Okay? We'll talk about that. I'm going to try to avoid that. So anyhow, that's pretty easy, right? Okay, well, most of these are pretty easy, but you got to keep your wits about you. Okay? Try another one. Well, that's supposed to be an E. I'll read it to you in a minute. E didn't come out well, and I tried to fix it, made it look more like a C. Now, this is at least a step more complicated than the last one. Okay? And I'm going to go ahead and do it for you. But first think of what you would do first. Anybody got an idea? Don't say just, I don't know. Or, wrap your knuckles in your head, say, I think I've got it almost. Anyhow, that's all we're going to do. Okay. So AB plus C equals DE plus AB. And we want to solve. I didn't say what we want to solve for. Well, I'm going to make this one easy. Let's just solve for C. What do you think you ought to do first? Well, I think the first thing you better do is subtract AB. Because we subtract AB minus AB is 0, and that's going to leave us C, isn't it? And of course, if we subtract AB on one side, we got to subtract it on the other side. Subtract AB, and then I wrote both sides. It's not written real well. You might or might not be able to see that. A lot of times, you're going to be told to solve it like this. You put a couple of minus ABs down here, and then you put all this together in the left, you put all this together in the right. The way I say it, once you see you do it, for reasons it'll become clear later when we start actually combining multiple equations, is you put an equal sign between these, which nobody seems to teach anybody to do. Because now we're adding two things that are equal to two other things that are equal. If I add two things that are equal to two other things that are equal, then I'm going to get two things that are equal. And why people just say, write this down here and do the arithmetic without explaining how that fits into the whole rule system of mathematics totally escapes me. Somebody please explain this to me. But anyhow, it could well be a good reason. There are a lot of people out there who know more than I do. Well, when I add these, I also put a line below to say that I've got to add this to this side. I've got to add this to this side. Then I write out what I get. I don't just say, okay, AB goes away, right? I write it out and I get AB plus C minus AB because that's what I get when I tack a minus AB onto AB plus C, okay? And I get DE plus AB minus AB. And now I really don't have room to write out solution. So I'm going to come up here and rewrite that step. AB plus C minus AB equals DE plus CB plus AB minus AB. And I didn't really have room to write it. It's the same thing. And what you can see is I've got AB minus AB here, which gives me 0. And that just leaves me C. And then I've got DE plus AB minus AB. AB minus AB leaves me 0. And I have DE. So that was actually pretty simple, as long as you see that I got to subtract AB from both sides. Now, at this stage, I'll see people trying to divide both sides by AB because that's what we did up here. But, we divided both sides of this first equation, AB equals CDE. We divided both sides by A in order to solve for B because A was multiplied by B. So if we want to get rid of a multiplication, we're going to have to do a division. We have to do it on both sides, okay? Here we have AB, we're trying to solve for C. We've got AB plus C. So if I want to isolate C, I don't divide by AB, I subtract AB. Now I'm emphasizing that because it's such a common error to do things kind of by rote without thinking about the rules. The rules are not that hard to understand. I mean, you undo an addition by a subtraction. You undo a multiplication by a division. You undo a division by a multiplication. All right. Um, so, okay, here's one that we want to solve for A. Take a good look at it and tell me what you think you might want to do. I need a little more board space. Let's see if I've got it. Yeah, I've got some. Okay, what's the problem here? The problem is A appears on both sides. Okay, so this is a little different than before. If A appears on both sides, then I've got to add, subtract, multiply, divide, whatever, by something to get all the A's on one side. So what I do is I usually like to get the variable I'm solving for on the left-hand side. So I'm going to take A and add it to the right-hand side, and that'll add to the minus A and give me 0, and then I won't have any more A's on the right-hand side. On the left-hand side, well, I'm also going to have to add an A. So the equation reads A plus C equals BD minus A. I add A to both sides by writing the equation plus A equals plus A. You don't really have to have the plus A. You could say A equals A, but having a plus there reminds you to add it and avoids carelessly doing something else with it. Okay, so then I have on the left-hand side, on the left of the equals, one equation has A plus C, the other has plus A. Well, that gives me A plus C plus A on the left-hand side. On the right-hand side, it has BD minus A plus A. And I'll go ahead and write that down, BD minus A plus A. Now we can see that the right-hand side simplifies down to just BD. And A plus C plus A, well, I've got an A plus A. If I've got an A and another A, I've got two of them, so I've got 2A. I've got 2A plus C equals BD. And then what I want to do is I want to get rid of that C. So I can write down the equation minus C equals minus C. Now again, your open math homework is not going to include the equal there. I say include the equal so you are rigorously correct. And so you anticipate something I have to do later. So you understand you're adding two equations, okay? Well, I'm going to write down 2A plus C minus C equals BD minus C. BD minus C doesn't simplify. 2A plus C minus C does simplify. C minus C is 0. And we're left with 2A equals BD minus C. And now the rest is quite simple. We want to find A, and we've got an expression for 2A. We just divide both sides by 2. And now I went and hogged up all the space I had left, and I don't have much anymore, but I'll write it in a little different color so we can be sure we see it. This tells us that A equals BD minus C over 2, and that's two scrunched together, but I think everybody understands that. And let me make one more comment. Rewriting A equals BD minus C over 2 could also be written A equals BD over 2 minus C over 2, because the 2 divides both the BD and it divides the C. That's an application of the distributive law. Okay. And I see errors with that kind of thing. Now, I would leave it in the original form, A equals BD minus C over 2, unless you have reason to separate it out into BD over 2 minus C over 2. The former expression is simpler. Okay. This expression is expanded a bit from the original, but it's still a good expression. And sometimes you would want one of these over the other. Okay. So that's really not too bad. Now, Open Math will show you a couple more complicated situations. But I want to just make sure we are comfortable with the symbols and the most basic operations. And then we'll talk about next time. I'll give you a couple of problems and see if you learn what Open Math is teaching you. And we'll correct that if necessary. Clarify it. Okay. Now, the other topic is inequalities. So just to illustrate, I'll solve a simple inequality. Three x plus 4 greater than 5. Well, it's perfectly all right to add an equality to an inequality. Okay? That's going to give me 3x plus 4 minus 4 is greater than 5 minus 4. If you have something greater than something else, and then you add the same thing to both sides, left-hand side is still going to be greater than the right-hand side. Okay? You got somebody that's bigger than somebody that weighs more than somebody else, and hand them each 2 milk jugs full of milk of equal weight. The one that weighed more is still going to weigh more, right? It's very simple. Okay, so obviously we're going to get then 3x is greater than 1. Now we want to solve for x. Well, we can still divide or multiply both sides, okay? Now there's a rule that goes along with multiplying or dividing the same thing on both sides, okay? Multiplying and dividing by the same thing on both sides. But that rule isn't going to interfere at this point. We get x greater than 1/3. And then we draw ourselves a number line. Here's a number line. Here's x. We put a scale on it if we want to. And we draw the line, the vertical line, x equals 1/3, which gives us the point on the graph where x equals 1/3. Then every number greater than 1/3, well, greater than 1/3 is all the numbers to the right. That real clear? Make sense? So we go ahead and draw ourselves an arrow. And the arrow goes to the right. It starts at x equals 1/3 and goes forever to the right, because any number to the right of 1/3 is going to be greater than 1/3. One thing we don't do is we don't include 1/3. So this is one little anomaly. I'm going to put an open circle around the point where x equals 1/3 to indicate that x equals 1/3 is not included in the solution, because 1/3 is not bigger than 1/3. It's equal to 1/3. It's not bigger. Okay. Now there's more with that convention, but that's actually fairly simple. So let's try another one. Let's try 2x plus 4 is greater than 5 minus 6x. Now, we're going to have to get the x's on one side. So I'm going to write the equation 6x equals 6x. Then the left-hand side is going to be 2x plus 4 plus 6x equals 5 minus 6x plus 6x. I'll put pluses on those 6x's here. Okay, so it reads 2x plus 4 greater than 5 minus 6x. And below that, the equation plus 6x equals plus 6x. When we add the left-hand sides, we get 2x plus 4 plus 6x. Add the right-hand sides, we get 5 minus 6x plus 6x. Well, the right-hand side then, minus 6x plus 6x gives us 0, and that just leaves us 5. And I've been writing equal signs, so let's be careful. When I add the 6x's on both sides of 2x plus 4 greater than 5 minus 6x, I get 2x plus 4 plus 6x greater than 5 minus 6x plus 6x. I treated it like an equality before, and that's not correct, okay? So anyhow, on the right-hand side now of the inequality we have 5 minus 6x plus 6x, which is just 5. Then 2x plus 4 plus 6x, 2x and 6x is 8x. Then we have plus 4. And then what do? Well, we subtract 4 from both sides by writing the equality -4 equals -4 and adding it to our existing inequality. And we get 8x plus 4 minus 4 greater than 5 minus 4. Which gives us 8x greater than 1, x greater than 1/8, And the picture looks a whole lot like the one we had before. Now I did a bonehead thing here. I wrote minus 6x on the right-hand side when I meant to write plus 6x so I could illustrate something. So I'm going to go through essentially the same equation, but now it reads 2x plus 4 greater than 5 plus 6x. And again, I want to get the x's on one side. So I write minus 6x equals minus 6x. And then I add the left-hand sides and the right-hand sides. Left-hand sides are 2x plus 4 and negative 6x. So I get 2x plus 4 minus 6x greater than 5 plus 6x minus 6x. Steps are very similar to what we did before at this stage. 2x minus 6x is negative 4x. And then we'll still have the plus 4. And that's greater than 5 because 5 plus 6x minus 6x, 6x minus 6x is 0, just leaves us 5. Okay. Then we add negative 4 to both sides. And we get negative 4x plus 4 minus 4 is greater than minus 4. Five minus 4. And we have negative 4x is greater than 1. And this is a step I really wanted to emphasize. Okay, negative 4x greater than 1. We divide by negative 4. So negative 4x over negative 4 on one side and 1 over negative 4 on the other side. Now, previous step was negative 4x greater than 1. We divide it by a negative. If you multiply or divide by a negative, it reverses the inequality. So greater than becomes a less than. Okay? We'll see that that works out real quickly. So this leaves you x less than negative 1/4. So on our number line, we indicate x equals negative 1/4. And we put a circle around the point where x equals negative 1/4, an open circle. And we draw our arrow to the left. Crooked arrow because I had some interference down here and failed to overcome it properly. Okay? So this inequality, which started as a greater than, ends up as a less than. Now you're going to get some explanation of why that's so in open math, but just remember, it's just like dealing with equalities, except that if you multiply or divide by a negative on both sides, you got to reverse the direction of the inequality. And you could check this, we're out of time, but I could take any number less than negative 1/4 and plug it in here, and it's going to be true. Like if x equals negative 10, I get negative 20 plus 4 is negative 16. I get 5 and minus 60 is negative 55. Negative 16 is greater than negative 55. If it's 16 below 0, you're in a lot better shape than if it's 55 below 0. And we can kind of relate to that since we've had some mild sub-zero temperatures recently. And maybe we'll talk about wind chills. It was somewhat lower than that. Okay, so that should give you what you need. The assignment on inequalities won't be due until Friday, but then we'll have 2 more assignments due over the weekend that we'll talk about on Wednesday.